two muffins are in an oven. One says, boy, it's getting hot in here. And the other says, a talking muffin! The Taylor series about x equals 5 for a certain function f, this is blurry, converges to f of x for all x in the interval of convergence. The nth derivative of f at x equals 5 is given by f nth derivative evaluated at 5 equals negative 1 to the n times n factorial over 2 to the n times n plus 2, and f of 5 equals 1/2. That's a confusing sentence. Right, the third degree Taylor polynomial for f at x equals 5. That is not a confusing question. That's a very straightforward question. Third degree Taylor polynomial, I know what those look like. Third degree polynomial of x equals, first I do the 0th term, the 0th derivative to the 0th power over 0 factorial. I do the 0th derivative, meaning the regular function, evaluated at the center, x minus the center to the 0 power over 0 factorial. First derivative. First power. First factorial. Second derivative. Second power. Second factorial. Third derivative. Third power. 3 factorial. If I had to imagine you getting this problem wrong, I would guess that you would forget to do x plus 5. Remember that's going to be x plus 5. Not plus. I'm getting it wrong now. X minus 5, because it's centered at 5, so everything needs to be in terms of x minus 5 to a power. I need to figure out what these come out to. So let's see. F of 5, I know. F of 5 is 1/2. F prime of 5 I'll plug a 1 into my formula. I get negative 1 to the 1, 1 factorial, 2 to the 1, 1 plus 2. That's going to be negative 1 times 1 over 2 times 3. That's that one. I need to figure out what second derivative of 5 is. That's going to involve plugging a 2 into that formula. I'll do negative 1 to the second power, 2 factorial, 2 to the 2, 2 plus 2. That's 1 times 2 factorial over 4 times 4. And a good probability question, just while we're talking about math, is what's the probability I get all of these right and then no one comments on this video saying, oh, Mr. Novik, you made a mistake? Probably I get them all right is 0. I'm going to plug a 3 into the formula. And so it's going to be negative 1 to the 3. 3 factorial. That's a 3 factorial, not a 31. You know, I said it. You know, I don't need to fix the handwriting there. 2 to the 3. 3 plus 2 equals 1 times 3 factorial. 3 factorial is 6. Negative 1 to the third. So it's negative 6 over 8 times 5. So when I take these answers and I plug it into here, 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 and here, my whole thing is going to come out to P3 is 1/2 times x minus 5 to the 0 divided by 0 factorial. I don't write those because that's times 1 divided by 1. Plus negative 1/6 x minus 5 to the first power divided by 1 factorial. I don't write the divide by 1 factorial. But you can. You know, you do you. Whatever you want. Plus 1/8. I'm going to hold off on writing that. I'll write it. 1/8 x minus 5 squared times 2 factorial. Plus negative 3/25 x minus 5 cubed with a 3 factorial on the bottom. That's my polynomial. Lovely. Isn't it a lovely one? Find the radius of convergence of the Taylor series for f about x equals 5. Radius of convergence, that involves me doing some ratio test. I take the general term. So let's see. My general term is my super general term, my formula term is f nth derivative that's what my formula looks like. The general term for this particular series is going to be plugging in this for this will tell me what this particular series is. So my general term here is going to be negative 1 to the n factorial over 2 to the n plus 2. That's me just doing that green box. But I still have to do times x minus 5 to the n over n factorial. My general term in this series is going to be negative 1 to the n. The n factorial on top and bottom are going to cancel, which is kind of nice. And I'm just going to have x minus 5 to the n over 2 to the n plus 2. So that's what I'm going to use to do a ratio test on, figure out what x can be that will still pass the ratio test. So for my ratio test, I'll do a limit as n approaches infinity of a sub n plus 1. Plug an n plus 1 in for n. Replace all the n's with n plus 1. I end up with n plus 3 in this spot, because if I do n plus 1 plus 2, I end up with n plus 3. Ratio test in general looks like, I'm writing sideways, because that's cool. This is my an plus 1. To divide by an, I'm going to multiply by the reciprocal of an. So I'll do times 2 to the n on top. N plus 2 on top. Negative 1 to the n on bottom. X minus 5 to the n on bottom. This limit is going to be, some pretty things are going to cancel. Negative 1 to the n plus 1 and negative 1 to the n. That's just going to leave a negative 1 on top. Not that it matters, because it's absolute value. That negative 1 is not going to affect anything once I do absolute value. And I have a x minus 5 to the n plus 1, and I have an x minus 5 to the n. That's just going to leave x minus 5 on top. And I have a 2 to the n, which is going to get canceled out by part of that 2 to the n plus 1. It's just going to leave a 2 on bottom. And all that I have left over is a n plus 2 and an n plus 3. Remember, I'm doing the limit as n approaches infinity. As n approaches infinity, I'm going to be in kind of a eats DC, eats DC type situation, where the exponents are the same. The exponent on the n are to the first power and to the first power. So I divide coefficients. So all it comes out to is this. And ratio test says in order for this to converge, this has to be less than 1. I'm going to need x minus 5 over 2 to be somewhere between negative 1 and 1, which means between negative 2 and 2 has to be x minus 5, which means that 3 is less than x is less than 7. I really didn't need to go this far, but now I can for sure see my radius of convergence. On my number line, not that I need to write a number line, but just so that I can see. 5 is where I'm centered, and I go up 7 and 3. In this interval, I converge. This is an interval with a radius of 2. My radius of convergence equals 2.